These are notes for lesson 30, special lines in triangles. And the special line we're going to look at or focus on in this lesson is called the median. Okay, so to start with, what they have is some review from last lesson, which was on mid segments. So let's start with the first one. It says side DE is parallel to blank and measures blank the length of blank. So DE is this mid segment, and it is parallel to AC right here. So it is parallel to side AC. Also measures half the length of side AC. Okay, and then we had DF, which is another mid segment. All these triangles have 3 mid segments. That one is parallel to BC, and it measures half the length of BC. The third mid segment was EF, and it is parallel to AB and measures half the length of AB. Okay, let's start with the new stuff now. What we're going to learn about in this lesson is called the median of a triangle. And just like mid-segments, there's 3 of them. They are a little bit different than mid-segments. They kind of work like this. So let's say we have a triangle. Here's our triangle. And we have, these are the vertices. So we have A, B, and C. Okay, the way the median works is it goes from the one of the vertices, and it goes and it splits the opposite side into 2 equal sized pieces. So if we start at A, the median would go right like this, and it would split side BC. So it ends up at the midpoint of side BC. Okay, and then we had another one. We'd have another one from the vertex B that's going to side AC, and it's going to split that side into 2 equal sized pieces. And then the third one is going to go from vertex C, and it's going to go and split side AB into equal sized pieces. And notice right here where all 3 of these medians cross, and they're always going to intersect somewhere. That place has a special name. It's called the centroid, and you will need to know that name. So where all the 3 medians intersect, that's called the centroid. Okay, so let's write that down. So they all intersect at a point called the centroid. Okay, so what are some of the properties of medians? So we're going to focus on 2 properties. The first one we've already written down, which was this, that they all intersect at a point called the centroid. And then the second property, and this is kind of different, so let's make sure we get it right, is the length from the vertex to the centroid is twice the length. So 2 times, so it's twice the length of the centroid to the opposite side. Centroid to the opposite side. The opposite side. Okay, so let's go back up and look at our picture and see kind of how that works. Alright, so let's look at the median that's running from vertex A to side BC. So if we take from A to the centroid, let's say it's going to be 6, then by that second property, if we go from the centroid to side BC, it's going to be half of 6, which is 3. So the total distance is going to be 9. Alright, let's do some examples. We have example 1. It says, in triangle ABC, the medians are concurrent at F. So remember, point of concurrency is where they all meet. So that's the centroid. We have DF is equal to 4. I'm going to put these in. So DF is 4. BF is 16. Okay, so that's this side over here. AG is 30. So that's this whole line right here. So this whole median is 30. And then they want us to use that to figure out all these different measures. So let's see, FC. Alright, so if it's DF is 4, FC has to be twice 4 because it's running from the vertex to the centroid. So FC is going to be 8. And then we had DC, which is the whole median, so 8 plus 4 makes 12. Then we had AF. Okay, so AF, alright, this one's interesting. The whole thing AG is 30 right here. So we have to think, okay, this from A to F, it gets 2 parts of the 30, and F to G gets 1 part. So we're going to end up having to divide the 30 by 3, and we give 2 of the parts to AF and 1 part to FG. So AF is going to get 20. So 20 for AF. And then BE, okay, so BE, we had the 16 from BF. So if we go FE, it has to be half the 16, so it's 8. And if we add those two together, we'll get the whole thing. So 16 and 8 make 24. Okay, and then FG, we already sort of did. We had the 2 parts making AF, so the 1 part's going to be 10. The 20 plus 10 makes 30. And then EF, we already did. We ended up with 8 for it. Okay, let's look at the next 3 problems. On number 1, we're trying to find SN if LN is 5.8. Okay, so LN is this whole thing. And then that means SN, since this is a median, it's going to split this into 2 equal pieces. So all we have to do is take the 5.8 and divide it by 2, and we will get, let's see, 2 goes into 5 twice, we get 1 left over, so 2.9. So SN is equal to 2.9. Number 2, I'm trying to find XL if LB is 7.4. So LB is this little part right here, and then XL is this part. Okay, so it's both of those are parts of a median. The XL is the big part, so it's twice the smaller part. So we're going to do 7.4 times 2. And we will get 8 and 14, so 14.8. And the last one, we have find x if uj is equal to 5x minus 2 and uh equals 4x. So we're going to have to do a little bit of algebra on this one. We're looking for x, we're not looking for the side length, so that's good. That'll save us a little bit of work. So we have uj, and I'm going to write these in so I can see where they go. So uj is this part. It's 5x minus 2. And then uh is 4x. Okay, that's not too bad. That's a side that's split by a median, so this part's going to be equal to this part. So to make our equation, we just do 5x minus 2 equals 4x, and then solve for x. Alright, so I'm going to subtract 4x from both sides, and I will get 1x minus 2, and there's nothing over here on the right, so it's 0. Then we'll add 2, and so x is 2.